The symposium will start at 9.
So please open your applications, your GeoGebra applications, and the task, the problem that we are going to be discussing here is going to be a kind of simple problem to begin with. And little by little, we are going to transform this problem into an activity. The idea is to activate some calculus concepts. So this is the question that we want to explore. Can you draw a rectangle if you know its perimeter and its diagonal? It's a very simple question. So actually, a square is studied at elementary school. So some of the tasks, for example, that we have been using, they are simple ones. And by asking questions, we transform that task into a set of non-routine, sometimes tasks. So the idea is to construct a dynamic model of this problem. So let's start using GeoGebra. This is just keep in mind the question. Can you draw a rectangle if we know the perimeter and the diagonal? Okay, this is the GeoGebra. You should see in your computer something like this. Something like this. And if you are not familiar with the use of GeoGebra, don't worry, it's kind of simple tool to use. That part is the set of commands that we use to do the construction. And this is the pointer. This is the home command. And for example, if please, my friend is clicking here. This is the menu that we have. You know, for example, if we want to draw a line, we choose that one. If we want to draw a segment, we choose that one. And for example, we are going to remember the task was if we could draw a rectangle, if we have the perimeter and one diagonal. So let's represent, for example, the perimeter. So here, please, whatever. This is going to be the length of the, let's say, half of the perimeter.
So we pick up a segment.
Segment here. Here, segment here, you know, in that.
Okay.
And then you go here, push it, and then this segment.
Yes.
And then when the segment is activated, go look.
Yes.
That means that it's activated. So you can go and select 2 points, and then you draw the segment. Okay? That's a very, very kind of simple way to represent. So this is the geometric representation of the perimeter, a segment. So what we do, we just okay. There is one command here. Show Matthias what you did here, and then appears something like this, and then you just test. Try something. Yeah. Okay. 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 Now, what we are going to do is to just draw the segment that is going to represent the diagonal. Anywhere, just put it here. This is the diagonal. So this is the given information, perimeter and the diagonal. This represents the perimeter, and this is the diagonal. So with those, okay. Now,
Sorry, I messed up. I wanted to click here to add and then make this point. Should I say the
so what you know, you always you have to go back to that one.
And
That,
then I pick up this. Yes.
okay,
Thank you.
okay, okay. So we have that. So now, these are the data. This is the half of the perimeter, and this is the diagonal. So with those elements, we are going to try to draw a rectangle, which was the question, the task that we want to achieve. So now, what we are going to do is to pick up a point, go to that set of commands, and there is one that is point on object. Because we want the point to be on this perimeter, semi-perimeter. So that here. So that point can be moved within the segment. That's okay. Keep in mind that always this is the very important step. Whenever you do any construction, you go home and then you can control everything. Because if you don't go to read, the last command is active. So in this case, this is the pointer. This is the home command. Okay. So now the idea is to draw with this information to draw a rectangle. One of the sides is going to be this one, and the other is going to be that one, using that information. So what we are going to do is to draw a perpendicular line from here to the segment. We are going to draw the rectangle. So you need to go to that command and choose a perpendicular. Matthias, go here. Here. No, it's not. Okay. There. Okay. Choose that's perpendicular, and then you just go and click the point and the segment, and you go directly. Okay? So this one is going to be one side of that rectangle. This one, from A to E, is going to be. And the other side is going to be that one. So to do that, so we are going to draw a circle with center here and radius here. Okay?
Circle with the center through a point.
Exactly. On a point. Okay.
Make another point for me. Oh no. Okay.
Exactly. That's it. Yeah.
But how I stop this?
Just when you get the point, that's it. Okay.
So
Yeah, that's it.
No, but see if I move, it changes.
Okay, just there, and then just click there. Yeah,
Okay.
that's it. Yeah. Perpendicular. Yeah. Okay. Okay. Okay, so we have this. Keep in mind that we want to draw the rectangle whose perimeter is going to be twice this segment. That's the key part. Okay? So now, if you have that, now we go here and pick up the intersection point here. You know, this is the icon. Go to the first, yeah, the first command. Exactly. And then go here and the application. Just go directly. Okay.
How did you got the dotted line for the circle?
You mean this?
Yes.
Okay, Matthias. The dot. Choose with. Go here.
Yes.
Okay, go here, and then go. No. How did you dot? ¿Cómo pusiste lo? Yeah. Okay. Okay. Go to that command, and then with that, you are going to this is going to display that one.
For me it was just settings and then I got confused. It says settings and then settings style.
No,
Yes.
that's right. Yeah.
Line,
Style, and then you dot. Yeah. Matías, no hagas cosas sofisticadas todavía. Yeah. Okay. Yeah. Exactly. That's a kind of fancy thing at the end. Okay. So now, so we go to that command intersection, and then you choose that one. It's active now, and then you just go and pick here. There. Okay. That's it. So now, so we are going to do is draw a perpendicular to this line that goes through this point. Yeah.
A perpendicular line to which point? To Z, E, to the point Z.
That's right. This is the intersection point. I don't know which letter you have. Yeah. I mean, because the application put the yeah. Okay, and now again go to the intersection point here, and just click here. Here. There. Yeah. And get the other one. Okay? So we have, you know, this is the perimeter of this rectangle is this one plus this one plus this one plus this one. That's the perimeter, which means that is twice the length of this segment. Okay? It's just a straightforward construction. Okay? Okay, so yeah, you know what he's doing is he went to that pointer command, and then just move with the hands, that hand that appears over there, and move it. Okay? Okay, so you know, visually we know that this is the rectangle visually. But for the application to recognize that this is an actual rectangle, we have to define it. So we have all the elements to define it. So we go now to this command. This one, which is the that's a polygon. We choose polygon. So this command, what it does is to, and then you have to activate this Matthias. Okay, now it's active. this command. And then we just choose point, this one, this one, this one, this one. Just polygon. Just polygon. It's not regular, just polygon. Yeah, it's any type of polygon. Yeah. Yeah. Okay?
So basically you have to choose E twice.
Each point
Yeah, but
to close it. Yeah.
E twice to close.
Exactly. Yeah. Go here, 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 and finish there. Okay? And so you are going to have something like this. Something like this. Yeah? Look, here, the application gets the area of this polygon here. Here. This is the area. Anytime that we draw a polygon, the application is going to show the area. So it's fine? Everything is fine?
No, I can't find the area.
Oh, no. No. What happened is that, you have to check here.
Yeah, I'm looking there.
Actually, exactly. Is the polygon? Here. This is the area. Your area.
This just
Exactly. If you move the point, go to the pointer, the area is going to change.
exactly what I'm trying.
Yeah. Yeah.
Oh, yes.
Yeah. Excellent. Excellent. Okay? Okay. So, this is the area, in this case, for this polygon. And so if we move that point, you see that this value is going to change. Look. Go from 0 and then again 0. So one question is how that changes. And the idea is to draw a graph of this area variation. So that's the idea so to do that, there are different ways to represent the area variation of this family of rectangles that they share the same perimeter. Okay? So look, for example, move this, please, Matthias. Okay, so there are things that change, for example, the area, and also, for example, the position of this point is also kind of, So we can ask just to use that command. Go here, Matthias, and check the locus command, that one. Locus is the last one? Okay. Okay, so activate that command, Matthias. Here. And then choose that point, this point. And that point. And this one. First, the intersection point, and then that one. Look. That's the locus of this point when this point is moved. Okay, again. Okay, choose the pointer command.
No, I did that just now. My high school mathematics knowledge is missing. That locus, what is that?
Pardon me?
Locus.
Locus.
It's something you were teaching yesterday.
Yes, locus. That's the command, which basically is the path left by this point when you move that point. How that move?
Geometric.
Exactly.
Yeah.
Exactly.
Lost in translation.
Yes.
I know.
Yeah. Okay. So, uh, so the
Excuse me again. Now when I did, no, sorry.
it's okay, okay. So what? So when you move this point, a family of rectangles appears in this, and so all of this family of rectangles, they have the same perimeter. So which means that there are infinite numbers of rectangles. So if you choose any point here and you draw the rectangle, that rectangle is going to have as a perimeter twice this segment. So all the inscribed rectangles in these right angles share the same perimeter. The same perimeter. That's geometrically, that's the meaning. Huh?
X plus I equal a constant. It's a line.
That's right. That's right. Exactly. That's that's right. Exactly. That's the geometric interpretation of that. Yes. Okay. So now the idea is to graft the area variation of this family of rectangles. So to do that, there are different ways to do that. One is for example, we are going to define a function with independent variable. Let's say this length of this side, and the y coordinate is going to be the area of this rectangle. For example, in this case, Q1 is the area for this rectangle. So what we are going to do is to draw a circle here, circle. Center and radius, exactly. Okay, and then choose that point, E. That point, E. And no, you have to activate the comma. Okay. Okay, and ask for the radius. The radius is going to be Q1, that one. Okay, do it, and then we repeat that.
Equals the center and radius.
Click
the center. And right. Right.
Yeah, that's the command. No, depends on your.
Where to find it? It's not
Here, when you say you may say polygon, and then you have one number here.
it's area.
Yeah.
It's area.
Does not comes with a unit. So if I cannot read the unit myself, I don't know what it is.
Yes.
It says 4.56. What is 4.56?
Which do you mean? Yeah, the units. Yeah, you know the system that you have. It gives you the units. So what you are doing here is, for example, in this case, centimeters in this case, and when we focus on the parabola, this is going to be square units.
I know how to define it, but the software does not provide you. If someone see the data,
Yes.
so it says you can see Q1 equal 4.56.
Yeah.
So it does not have the units next.
Yes. You're right. Actually, this is for default. Any times that you define a cross polygon, it gives you the so that number represents square units. Okay, that's yes. Yeah. Actually, we can even define another system. To exactly. Yeah, exactly. Okay, okay. So now check this point here, Matthias, please. Intersection point. That one. Remember that the radio of this circle is Q1, is the area value. So if you define the coordinates of this point, please, Matthias, go to this point. And show the coordinates. Yeah. No. Put it. No. Go. No. Choose this one. And now el botón derecho, como le llamas, ponlo a eso. That's it. And now look here. Go here. Object properties. Okay. And now go to basic. And here. Go here. And for that one. Name and value. Okay. 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 So if you look at the coordinates of this point, the intersection point, is what is 1.2? 1.2 is the distance from A to E. This is the one side. And that number is the area. So this is the meaning of these coordinates. Is one side and the corresponding area of this rectangle. So, for example, now we can ask about how that point behaves when we move point E. O el lugar geométrico. Okay, and then we move. Look.
Okay, Amos.
It was too fast.
So we ask for
Locus.
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 Locus of
Yeah.
it's called H. If me, it's called J.
Okay. I don't know which letter you have.
Your, it's J.
Yes, that's right. That's right. And you just check your phone and ask for the locus. Yeah. Go here. Locus of that point, J, when point E move. Look. Something. Did you get something like this?
I get nothing. I'm doing something wrong. So I choose locus, correct?
Yeah.
Locus. Then I click on H.
Yeah. And then E.
E, I forgot.
Yes, you got it. Okay. Okay. So this is the area variation of this family of rectangles. Okay. Another way to find this area variation is also defining the algebraic model. So we are going to do that here. If you define here in this command input, so the area of this rectangle, as you know, is this side times this side. This is the area. Okay? So we are going to give that input here. So let's call X, for example, A to E, let's call here X. X. This part. Here, we are defining the area. Luego, times, parentheses, to find this side, which is exactly the same, this one. So what we are going to do is to, this segment AB is the X coordinate of point B. Yeah? This segment A to B is the X coordinate of point B. Okay, so put that here. This X coordinate of point B, that's the syntaxis. Minus X, which is this one. X. And this is it's the same model. This is the algebraic model. ¿Cómo? Pardon me? X, let's call X here because it's going to change. You know, if you move that, yeah. So this is the syntax to define that, which overlaps with the locus. Overlaps with the locus.
Yeah, X is defined somewhere up.
X.
When we get point to that orthogonal, correct? It's called that X is defined up.
Exactly. Yeah. This is the model. This one is X times. This is the X coordinate of point B minus this one. Times is the start. Is yeah, because it's that less that one. Okay. Oh. Okay. So when you define that graph, the green one is going to appear there. Okay? Okay. Now, just for Matthias, click here in the the locus 2 here. No, key here. Click here. Yes.
Can I ask you something?
Sure.
I'm sorry about the question, but I'm a very bad student now.
No.
Like, why if the students are asking me, why are we doing all of this?
Oh.
What is the answer?
Okay. The answer is that.
Sorry for the question.
Okay. Sure. You know, we are doing this because, we are trying to analyze how, the area variation of a family behaves. Why is that important? Why is that important? Okay. Actually, the next step that we are going to do, we are going to connect with derivative. So that's the key part. So you start, by posing like a simple question, and then the issue is that, when you represent the task dynamic, you see different things.
So you are changing the shapes. You are going to change then the rate, how the shapes
Exactly.
Exactly. And then you can connect it also with
Exactly. That's the key part.
But you should write with the notes how to do it.
Yeah. That's the thing,
So
yeah.
you can, with an exam, you can show to them by visualization
Exactly.
the derivatives and the
Exactly, exactly. So the issue is that, normally when students go through these contents, they get isolated. In this case, you start with a simple question, and then you change the task, and you find concepts like derivatives to actually analyze. That's the issue.
And basically that locus that we figured out before and this area, they overlap.
Yeah, that's right. That's right. So the question is why I did that. The problem is that the application, the GeoGebra application, doesn't recognize the locus as an active object. And here, when we define the algebraic model, this is an active. What do you mean active? It means that, for example, look, I'm going to choose a point. Go here. On that here, anywhere, a point, anywhere, okay? So, and also, look, nothing, just point on the, okay? And now, so what we are going to do is to draw a tangent line that passes through that point to that graph. Look, there is one command, it's called tangent. So we go there, choose that here, and then choose the look. Okay, it's here. You go here. Okay, this is the tangent. Okay, this is the tangent. And also, if you go to this command here, and then there is slope. A slope. Of that. Exactly, that's the derivative. It's derivative. Exactly. So now you can calculate the slope of that line. Look, here is the slope. Here is the slope. Yes.
Do you have video tutorials of this?
Yeah. In YouTube.
So did you upload them to YouTube, or I was thinking about applying this GeoGebra for civil engineering purposes.
Sure.
For example, in civil engineering.
Yeah.
For example, you can have different shapes of channels.
Yeah.
Canals.
Yeah. Channels. Yeah.
In the form of parabola.
Yeah.
And then you have to, and then the limit is you have to have a maximum
Exactly.
perimeter, minimum perimeter,
Maximum.
maximum area.
Yes.
So I think we can do that.
Yes. Yes. No, definitely. And also there is a 3D version of this application.
For canals, for example, that means this is a hydraulically best
Yeah.
shape. There is in hydraulics, for example, there is a problem. How to find the hydraulically best shape,
Exactly. Yeah.
just to increase
The capacity, the volume. That's right. Yes. Yeah. Okay. So now, so what we did, we chose any point, and then we draw the tangent line, and we calculate the slope of that line. So if you look at the value of that slope from this side, From this side, please move this point. Exactly. You know,
So it shows to you how fast
that's right.
when you change the thing.
That's right. And also, you know, look here, for example, the value of slope is 0, which means that this is the point in which the area, move this, Matthias. Here, just look there. So this is the maximum area. So when you ask your students, find the derivative and equals to 0, that's the meaning. That is the meaning, you know? That is why you ask your kids, get the derivative and then solve it equals to 0 and find the values. So this is the meaning, geometric meaning. And if you move, look, if you move that point, here the value of the slope is 0, which means that that's the maximum for that. But if you go like this, is positive, the value of the slope on that side here. And after the 0, when you move to this side, it's negative. So which means that the value of the areas is going to increase 0 and decrease. So that's the meaning of derivative. Exactly.
So on the maximum point where the derivative is
0.
The surface that the polygon that you have designed has its maximum.
Exactly, area.
And then you are moving to the positive inclination.
Yes.
You are moving from higher to higher.
Exactly.
Surfaces and then.
Exactly. So keep exactly. You know, the idea is that, you know, students they have to have like a reference. So that's the model. When they study derivative, what is the meaning they make? So that's the issue. Look, now. So what we did is to, if you remember the initial question, the initial question was, if we have in this case the perimeter, the semi-perimeter, and you have the diagonal. So the question is, where is that rectangle? So here we have a family of rectangles, and then we move to analyze the area variation of that family, and so geometrically we solve the problem of finding the maximum value, which is when that rectangle becomes a square. That's the solution. But anyways, now what happened to the diagonal here? What happened? Okay, we haven't used it now. So far we haven't used it, but now we are going to use it. Matthias, draw a circle with center here and radius CD. CD, which is no, CD segment. Here, this is the one. Put it in different color, Matthias. No, you have to go to the pointer. Any color. No. just choose the circle, not the point, the circle. Yeah. Yeah. Okay. Okay. Look, this circle has as a center point A and as a radius segment CD, which was the diagonal. Okay? So, look, now if you move that point E, if you move point E to the intersection here, that's the rectangle that we wanted to find. Look, this is the perimeter is twice this, and the diagonal is this one. Remember that we use this segment to draw the blue circle with center at this point. So this is the radius. So this is the rectangle we are trying to find.
And then there is
The resolution.
and I was lucky enough just to get them to touch someone with the intersection.
Yeah. Two solutions. Well, it's your rotate. Yeah. And you know, this is a very interesting discussion in terms of, for example, when we posed the question, we didn't mention any number. We just say perimeter and diagonal. So the question is, what is the domain to actually have the construction? For example, if we make this is the diagonal shorter, move it here, move D. So what happened to that? Pardon me?
Yeah. Mirela is asking about, she has a question, is in the screen.
Huh? Yes, we have a couple of publications on that. So we share it with you. And you have
I wanted to find intersection between these two lines, just to get the point, and then I couldn't choose this slanted line.
yeah. You know? Yes, I know what you mean. You mean the circle and the segment? Yeah. You know what happened? Yeah. I tell you, the application, you know, doesn't have that. So you have to define, just choose 2 points on that segment. Look.
Like B, yeah?
And exactly. Just two, and you are going to draw a line.
A line?
A line, and that line you can intersect it. Yeah. Mm-hmm. Okay, hazla. Look, Olga. ¿Eh? Tienes que definir. Por eso tienes que poner la recta. Yeah, look, he's going to do that. Okay. No, just choose 2 points. Line. Okay, and then just 2 points. On another one. That's it. Just now. Do you see it?
Yes, and then where is the point?
Yeah, here. Ah, no. Esconde el lugar geométrico este. Ajá. ¿No te lo da? Es que creo que escogiste un punto, este punto no. Toma cualquiera, toma uno aquí y otro acá y ya. Sí. Ajá. Ajá. Eso. Ajá.
Yeah, and then of course those 2 points don't move when they move.
Exactly. Exactly. Stationary points. Exactly. Exactly. Yeah. 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 So anyways, so we can, pose different questions here. For example, if we change the length of the diagonal, Matthias, please change that length. Change, move point D or point Z. Look, for example, if less, no, the other side, here there is no intersection. So which means that for this value, you cannot construct the rectangle. So the question is, what is the domain? In which values you can actually draw this is a mathematical question. So in this kind of simple problem, you can pose questions that, demands the concepts, to use concepts that sometimes when you study functions, for example, the domain, how we are going to define the domain, are very important. So I remember your question, when to use this before actually going into the calculus concepts, or you combine, what do you do? In my opinion is that this gives you the whole picture of the subject. And then it makes sense to study derivatives, to find derivatives, when you say find the derivative and equals to 0, and then all that tools, you can have the referent, geometric referent. So that's the interesting part when you use this type of approaches. So if we have time, so 2 minutes? 5 minutes? Okay. Probably we can ask, you can ask questions, and so we can to close the session.
Can I ask something? I'm not sure how this works, so I'm online.
Sure, please.
Okay. First of all, thank you for these nice examples. I followed you from yesterday. I'm very interested to find out more, so thank you very much that you are going to share with us your publications about this. What I wonder is, have you tested this with students in the way not only visualizing and discovering these properties, but also giving proofs, mathematical proofs, and really showing the connection between, I mean, you talked about it, but have you tested this with the students? I wonder how it works in that case.
Yeah. We have used this type of approaches for teachers, high school teachers. So we have been doing is developing different tasks in which they have the opportunity to use this tool and other tools. So what we have now, if you remember, the title of the workshop was developing online courses. So the material that we have is available now, but it's not in English. That's
That's no problem, I understand Spanish.
Okay.
I just want to listen more about this because I really like it.
Yes. So now we are in the implementation phase. So if you are asking me for specific results to measure what happened when we use that, so we don't have it yet. So we have the proposal and we have the material, and teachers are now trying to implement this with high school students.
I understand, because we can talk about this some other times, of course, not here to take the time, but I think it's very interesting for our prospective teachers in Sweden, since they both study geometry and analysis in the same period, to make connection between these two parts and see the real importance of the visualization in the analysis part. So I like this from several points of view.
Yeah.
Thank you.
Thank you. Thank you.
Have contact in
Yeah.
that way.
Thank you. So, yes.
This is extremely rich example. I mean, you showed us that we can discuss so many things,
Yes.
different ways, introduce many concepts and all that. But this is one of ways of solving this problem. Would you also choose to show alternative ones? I'm just thinking intersection of one ellipse and one circle, maybe, or something like that. I mean, your original exercise
Yes.
has many different
Yes.
paths to solution.
To begin with, yeah.
So, would you also encourage students to go to another path?
Sure.
Or this?
No, actually, even for example, when you decide how to do part of the construction, there are different ways to think of.
That's what
Yes, yes. Actually, you know, this is just one path, but there are different paths. And also, when you choose a different one, you think of different concepts.
Exactly. I mean, I'm just thinking those students who might have, as I had in my head when you started, okay, that two paths I have diagonal, so it's just, isn't that just an ellipse over that, and then I have another constraint, and you never mention ellipse, and I have somehow feel, maybe my idea was bad, but it's just an idea.
Yes.
So what to do with students like that?
Yeah. Yeah, actually, you know, the idea is that they incorporate the use of the tool as a way of thinking. So there are different paths to do the construction, to pose questions. So to answer your question is, this is a tool that allows the students to reflect, to pose new questions, to explore things. It's just, this session was just giving a feeling how this can be activated. But there are different, we have a couple of publications on this topic, so we can share that and then keep the discussion.
So we are moving to the morning session of our symposium. And it's a great pleasure to have with us the next speaker that comes from the Karlstad University in Sweden. It's Maria Fogelken. I'm sorry that I cannot pronounce very well. Maria, it's easier for me. Welcome. Maria is a researcher and a teacher educator in mathematics education in Karlstad. Her research interest includes digital technologies, interacting and learning of mathematics, so how to use digital technologies along more efficient, I suspect, teaching and learning. Her talk today is entitled Task Design Using a Dynamic Mathematics Software Environment and the Computer-Aided Assessment System, Some Insight on Students' Perception. So Maria, thank you very much. The floor is yours for the next 40 minutes in order to give 5 minutes for questions. Oh, is it okay? So you can share your screen, and thank you very much for your contribution. Thank you.
Nej, det var nog fel med entire screen. Det blir det.
I'm sorry.
Gå på dela.
So, yeah, go to the arrow there,
Yes.
there. So you can share your screen there.
Yeah, a window.
Kanske måste ha PowerPoint eller något. Gå tillbaks in i rummet där. Select window igen där uppe.
So if you go to the present option, it will be the first one that it will say to share your full screen.
Full screen, okay.
Yeah, and then you go to your presentation.
Maria, igår använde jag ett fönster istället och sen klickade jag på min presentation så jag kunde se den. Det gick bättre för mig. I'm sorry, I said some things.
Yes, we
En gång till tror jag och så komma.
we tried that. I have started the presentation on my computer now, and but if I choose to share the entire screen, I will. This will be the view. So that's not the right.
Välj fönster istället i ett fönster.
Okay.
Funkade för mig.
So, instead, I should, as Mirella suggests, one
If not,
window.
we can show the presentation from here if you can send it to me.
So, perhaps, no,
Now it's working. Now go to full screen and that's it.
Can you see the presentation now?
Yes, we see it.
okay, so you can see the presentation. Does it work?
Yeah.
Now it's working fine.
Oh,
So we can't see you, but perhaps later.
okay, that's great. So, hello everyone, and welcome to this presentation. It's a great pleasure for us to introduce our ongoing project within a first year calculus course for engineering students at Karlstad University in Sweden. We are 4 people working on this project. So Mats Brunström, myself, Maria Fahlgren, Mirella Winnerjans, who is also with us here today, and Josef von Magigne. And we are, all of us is also involved in the iTEM project. The today talk will be made by myself and Mats, who will also continue after I have introduced this session. So let's start by providing some background. It all started at a coffee break in year 2015 when.
Just to see, can you see now the picture? of the coffee table?
Yes, we can see. It's good.
Fine,
Great,
thank
great,
you.
yeah. And when one of us, Mirella, expressed her frustration about her teaching of the first calculus course for engineering students, many students fail in my course, and she provided several reasons behind this failure. And one reason is that for first year engineering student, this usually means larger student groups, and it's not possible for a teacher to meet with individual students and guide their learning in the same way as at upper secondary school. And another reason is the diversity of students' mathematics background, and that many students have insufficient basic mathematical skills. And in comparison to the upper secondary school context, studies at university require students to be more self-regulated and thus responsible for their own learning, which is demanding for several students. At the same time, both me, myself, and Mats finished our PhD in mathematics education. The focus in our research has been on designing interactive learning environments in which dynamic mathematics software plays a central role. In particular, the focus has been on the design of exploratory activities where students are provided opportunities to explore and discover mathematical relations to foster a conceptual understanding in mathematics. It was during this discussion the idea of using the experiences from upper secondary school, use it at university level as well. And since this turned out well, today these activities constitute mandatory parts of the first year engineering calculus courses at Karlstad University. About 5 years later, our colleague Joseph attended the coffee break. Joseph had for some years worked with computer-aided assessment system, in this case Möbius. There are several important affordances provided by computer-aided assessment system, such as STAC or Möbius, as well as the possibility of randomizing values of variables and parameters for individual assessment. CAA systems provide opportunity for students to receive immediate feedback on their progress, which in turn provides support for their independent study by students. Although the exploratory activities worked well with the students, the workload in terms of correction work for the teacher increased a lot. And it is now that Joseph came up with the idea of using a CAA system to support the teacher in this time-consuming correction work by offering automatic correction of student responses. However, researchers point out the potential risk of such assessment focusing on lower order skills of mathematics and solely on the correctness of a final answer, because such types of tasks and feedback are most straightforward to implement in CAA systems. Accordingly, there is a need for designing CAA tasks that address higher order skills in mathematics, as well as for designing feedback that goes beyond categorizing a final answer as being right or wrong. So, these very fruitful discussions led us to start a project in 2020 with the overarching aim to develop principles to guide the design of a technology-enhanced learning environment, utilizing a combination of a dynamic mathematics software and a computer-aided assessment system. So far, we have conducted activities in 2 cohorts. involving almost 500 students. As part of the course assignment, 2 computer-based activities have been developed and trialed. To encourage student collaborations, students are supposed to work in small groups, typically 3 students per group. Each activity consists of a task sequence focusing on function understanding. However, since the activities constitutes part of the course assignment, there are individual elements embedded in the activities. In this way, the activities contain both tasks that require a group agreed answer and tasks that require an individual answer. So far, mainly 3 types of non-traditional tasks have been trialed. Firstly, tasks where students are expected to use a dynamic mathematical software, in our case, GeoGebra, to explore mathematical relations, to make conjectures, and to explain their empirical findings. Secondly, we use tasks where students are asked to identify the function formula for a given graph. We call this task as translation tasks. And finally, we have trial tasks based on the pedagogical approach of asking students to generate examples of functions satisfying certain conditions. This approach has been suggested as a way to engage students in developing conceptual understanding. The 2 latter types of tasks are particularly appropriate for computer-aided assessment systems since they allow for automatic assessment. Besides, before students submit their answer into the CAA system, they are encouraged to check them in GeoGebra. And next, let's look at an example of a task. And I give it over to Mats.
Yes, so first we shall look at an example of a translation task. And most often, translation tasks are from formula to graph. Lots of tasks like that in the calculus books. You get a function and then you should sketch the graph. But the other way around is much more challenging, and it also promotes discussions among students. So this is one example. Below is the graph of the function g. Use the graph to determine the function formula. And the students should check their suggestion in GeoGebra before submitting it as an answer to the task. So perhaps they can see their first try is not exactly the right form, the right graph, so they have to change it a little bit. And they can use GeoGebra to check their answers several times to finally find the correct graph. So, to solve this task, students have to, first of all, realize that it must be a rational function with 1 horizontal and 2 vertical asymptotes. And then they have to utilize the vertical asymptotes to construct the denominator. In this case, it will be x plus 2 times x minus 4. And then they have to utilize the horizontal asymptote to conclude that the numerator should be of grade 2 in this case, and also in this case with the coefficient 2 in front of the x squared term. And then they also must realize that they could utilize the zeros in this case or 2 other points to finalize the function formula. So there are lots of things that they have to use to construct the function formula here. Next example, we will look at is an example of an example generating task. And first, some words on example generating tasks. As Maria said, researchers suggest example generating tasks as a way to engage students actively in their development of deeper mathematical understanding. Since there are no general methods for solving these types of tasks, students have to be creative and develop solution strategies building on conceptual understanding rather than factual knowledge, factual recall. Furthermore, by prompting students to provide more than one example fulfilling certain conditions, they are encouraged to reflect on how the first example could be varied without destroying these conditions. So this pedagogical approach has been adopted by researchers in the creation of novel types of tasks appropriate for CAA systems, since it allows for automatic assessment of higher order mathematical skills. So let's look at one example that came after the example we just saw. Give examples of two different functions, f and g, both of which have two vertical asymptotes, x equals -6 and x equals 3, as well as a horizontal asymptote, y equals 2. And in this case, it's an individual task, so group members will have different asymptotes. And they should also check in GeoGebra in this case before they submit their answer into Möbius, the CAA system. So these are two examples of tasks. So we will tell you a little bit about students' thoughts about these activities. So we had a questionnaire at the end of the course, both 2020 and 2021. It was, of course, a voluntary questionnaire. And as you can see, we did receive more answers in 2021 than 2020. So we will look at some of the questions and the responses from the students. So we wanted the students' opinion on the level of difficulty of the three types of task. And in this diagram, the colors of the bars indicate the type of task. So for instance, you can see that the blue bars is about the exploration tasks and so on. And as you can see, most of the students found the level of difficulty neither low nor high. And there were also several students that found it pretty high, as a pretty high level. We can say that they found the level of difficulty as adequate, as we think, at least. So, in this question, we wanted the students to take a position on the statement that the tasks provided increased understanding. And we used the 5-graded Likert scale, as you can see. And as you can see, most of the students agreed or agreed strongly with this statement for all the three types of tasks. For students, it's very important that they use their time efficiently. And therefore, we asked them to take a position on this statement. The time spent on working with the activities was well worth. And as you can see here, most of the students agreed or agreed strongly with this statement. To ensure students' engagement early during a course and prevent students from waiting to work on course material until shortly before the final exam, we introduced activities rather early in the course, and therefore it was interesting to get their opinion about this. If it is it is good to have compulsory parts early in the course. And as you can see also here, most of the students found this arrangement as a good arrangement. They agreed or agreed strongly, most of the students. And next, we will present some questions concerning the use of GeoGebra. And since we encourage students to use GeoGebra to check their answers before submitting them into the CAA system, we wanted to know to what extent they did so. And if you look at the bars, you can see that most students answered most often when possible, and many students also answered whenever possible. So we can see that students really utilized this opportunity to a high degree. And finally, we were very interested in students' view on GeoGebra as a pedagogical tool. So we asked them, to what extent do you agree with the statement, working in GeoGebra provides an increased understanding? And as you can see, students really appreciated the use of GeoGebra to enhance their mathematical understanding. Very many answers were strongly agree or agree. So even if the tasks worked well, there are things to improve, of course. For instance, we need to develop the feedback from the CAA system so that it is formative and adapted to different student responses. There are still lots of work to do on this. And we have started this work, and as Mirella said yesterday, we will continue to develop tasks and associated feedback in the upcoming Erasmus Plus project, Pythagoras. So many thanks for your attention and welcome with questions.
Excellent timing, thank you. Are there any questions from the audience? Yes, Maria.
Okay, thank you very much for this very interesting presentation. Very inspiring. The first question is, how long do the students have to answer these tasks? And how many tasks do they have during the semester? Well, two questions. First, how many tasks do they have during the semester?
Well, we have 2 task sequences, and in each of them, there are approximately 10 tasks, I would say.
So one every week, more or less.
They get the tasks, so they have 1 or 2 weeks to work on these tasks.
Okay.
So they can work on them whenever they want to do that.
And they have 2 deadlines, so it's not only in the end of the course. They have, for the first part, because we want to put them to start to work directly in the beginning of the course, we have a deadline quite early in the course, and then in the end of the course. And we finish it with oral examination.
Okay, so these are compulsory tests.
Yes.
That they have deadlines in order to submit them. Okay. And do you have to correct all this? Because they're open answers. You know, it's not yes or no or multiple choice, so you have to go through it and correct it yourselves.
No.
No?
No.
That's the case with the CAA system, the computer-aided assessment system. The system could correct the answers.
Right, so it's like
But at
AI, you
least-
go through artificial intelligence and it's automatically corrected.
Yes, this is
Okay.
the new part of the project where we still are working and need to develop. This was what I complained before. I very much like to use all these GeoGebra activities, but I couldn't, and my colleagues couldn't
Yeah.
take so much amount of work in correcting that much.
Yeah.
But this programming in CAA systems help us a lot in this direction.
That's very interesting. Okay, thank you very much.
Thank you, Maria, for the question, and the colleagues from Karlsland for the answers. Are there any questions? One.
Assuming you have done all of the difficult work of coming up with the idea and implementing it, and let's say that another school wants to adopt your methodology, how difficult is it?
They should invite you to this cafe.
Of course.
I don't think it's difficult at all.
No.
No.
I can answer a little bit if it's okay,
Yeah.
Maria. The way we have it right now, Nissim, it's costing money because we use in Karlstad Möbus, and Möbus cost, it's a commercial program. But with the new project by Pythagoras, we plan to do this via stack, which is free of charge, and this would mean that when the material is prepared, it will be accessible and easy to use.
Excellent news. Excellent news. They don't need money from Pythagoras. They are going to do it for free. Thank you. And can I ask you a question? You apply all this methodology, but what is the impact to the success rate of your students during the exams? Before and after, I mean.
I think that's a tricky question because we have changed more than one thing when we started with this.
So you cannot see any impact apart of the students that they reply
I
more
think
understanding.
Mirella, perhaps.
Yeah, I think we can see, and it's maybe too early because we had it only checked 2 times. What I can see, it's not right now, not bigger % of students passing, not right now because we don't have enough feedback, formative feedback that goes in and helps all type of students. But what we can see is in the courses that come directly after, the students we send to the next courses, we send them with good results and they manage to be still our students. Before we send 50% and next course 30% succeed. Now we send 50% or maybe 60% and they are like 50% still after the second, the whole year courses, engineer courses. So I think what we do, it's just, it's still in theory, it's not really proved, but it's a tendency I see that we send better prepared students from this first course.
And I have a second question. I like the idea, I mean, you approach to the students to discover about the functions, starting from the graph to find the formula. But in the majority of the cases, if we are talking about experimentalists, the first thing that we have are data. So is there any particular reason why you have not used data in order to make the graph or to extract the formula?
We didn't thought of it, so thank you for this idea. Why not? I mean, I have in another course.
So I will take your money from Pythagoras
We
then.
didn't take it like a real test. We could do it. We could have such a test.
Okay.
That will be the next step.
Yeah.
Okay, so I think that we should conclude in order to move to the next session. Thank you very much, Maria, Matthias, and Mirella for the nice contribution. Thank you once again.
Thank you.
Thank you very much.
Thank you.
Thank you.
And let's move to the second contribution for the morning session from our colleague Nissim Harel. I think it's you. Nissim is a senior lecturer in Holon and also works in Hadassah. He has a very nice profile regarding his studies. He was an undergraduate student in Technion and then he moved to Georgia Tech to do his PhD. His research interests include data mining, big data, and healthcare IT. And he's one of the core members of the iTEM project. So Nissim is going to speak to us. The title of his talk, let me find my notes. It's going to be manuals for students and teachers. You are doing the second one now. So, all right, let me find out. Okay, so he's going to present us the impact and the results of the application of the iTEM project in Israel. Report from the trenches. So,
Sorry, is the coffee break?
It's a coffee break now. I'm not used about the coffee break, so we're going to have a 10 minutes coffee break, too many coffee breaks, one coffee break. So let's have, a stop for a quarter. I think it's enough for a quarter. 30 minutes. Wow. All right. It's a different kind of pace. Okay, so if they say 30 minutes, let's have a break for 30 minutes and then come back. We had just let's play some music here.
Quarter to 11.
Are you ready?
Yeah, for some reason it doesn't work. It's okay. It's okay.
Do you want me to do it?
No, it's okay.
I can do it.
Everything is fine.
Okay, so let's start. I think that we have all the people online with us. So we are starting after the coffee break. We have two contributions. One comes from Dr. Nissim Harel, and we are going to continue with Adrian Moudean, and then we are going to have the lunch break. So it's a great pleasure to have with us our colleague from Holon Institute of Technology, a senior lecturer over there, Nissim Harel. Nissim, as I told you, he has done his undergraduate studies in Technion, and then he moved to and then he did his master's degree in Israel as well. In Atlanta, in Georgia Tech, and the PhD in Georgia Tech. His research interest includes data mining, big data, healthcare, IT. He has an experience, if I remember well, from the market and from the industry. And he's going to speak to us. His contribution is in the title, iTEM Project in Israel, a report from the trenches. So I suspect that you are going to show to us what was the impact of the iTEM during your teaching in Holon and in Hadassah. So the floor is yours for the next 40 minutes. Thank you, Nissim.
So first of all, this is a result of work of many people, not only myself. It's also Dr. Lor Batel, Dr. Elet Butman, Dr. Dimitri Goldstein, Dr. Dvora Cohen, Frida Rybnukova, and Ronit Katz. All of them participated in this project in Israel, and this really is the culmination of all our work. I'm just presenting it. Before we start talking about how we implemented and what was implemented, it is very important to note what is the situation in Israel. The school system, which means the secondary school system, which feeds students in the academia, and the college system itself. So we'll have about 10 minutes about the Israeli society. I hope I won't bore you too much. We want to know what students are getting into the system. So the best proxy would be looking at the PISA score from 2018. And you see in blue, blue is the average at the OECD countries, and in red, this is the Israeli results. What is interesting to us is mathematics and science, which is here and here, and you see that the Israeli results is about 20 points less than the average in the OECD countries. More interestingly, you look here at the share of people who are, of students who are failing the PISA tests, and while the average in the OECD countries is 24%, in reading and mathematics, we'll look at the mathematics, 24% in mathematics, then the percentage of students failing in Israel is 34%. Which is significantly higher than, so here you can see the average of failure rate is 33%, and the question is, why? Where does it come from? And you see that because Israel is considered to be a very developed country, and so on and so forth, and you can see here that the inequality level in Israel is very high. So, for example, you can see here all of the 20-something OECD countries, and you see that the difference between the most equal, Ireland, and the less equal Germany, the difference is 15. 86, the difference between high achievers and low achievers in Ireland is 86. The difference in Germany is 101, and all the countries are somewhere in the middle. So the difference is about 15. The difference between Germany, the most unequal country in this list, and Israel is about the same. It's another 14. So the level of inequality in Israel is very high. So the question is, again, why? And the reason is because the Israeli society has 4, and I'm doing a really high level, it's more fragmented, but it has 4 different education systems. So on the top you see the red, it's about 56% of the, in 2015, about 56% of the population was in the red. What is the red? The red are Jews who are studying either in the secular system. We don't have a public system. We have a public system, but it is divided into Jews, Arabs, religious, and so on and so forth. So what you see in red are students who are studying in the Jewish, non-religious, and religious schools. This is about 56%. About 25%, this is the yellow, are students who are studying in the Arab system. These are schools that are mostly people from the Arab population, and you have 19% of the people who are studying in the ultra-religious schools. So we have 4 systems. 2 of them are combined together here to the 56, and then 25, and then 19. So what are the results of these people? So you can see here in blue, the top one is the Israel non-religious. It's the Israeli average was about 465. So the non-religious schools score 502. The religious schools, that again are the, according to the Ministry of Education system, they score 485. The Arabic speaker students score very low. They score 372. This is really low. And you remember that there were 4. So where is the 4th one? The 4th one is not measured at all. These are the ultra-Orthodox schools where they just don't teach math. They basically stop teaching math at the 4th grade or 5th grade. I don't remember exactly, but somewhere there they stop teaching math for the male students. The female students continue to learn math, but this is not on a very high level, and they are not measured at all. This is the situation in 2015, and if we go, again, this is demographic predictions, and are not as good as, they're not as accurate because we cannot predict how people will behave, but if current trends will continue, this is where Israel is heading. About 50% will learn in the ultra-Orthodox in 50 years' time, or for 45 years' time. Around 50% will learn in the ultra-Orthodox schools, 15% in the Arab schools, and 35% will learn in the...
How your economy will be sustained if, 47%...
A good question. A good question.
Who's going to work in your country?
A good question. I don't have an answer. Okay, so... So next, so this is the situation in the secondary schools. Now let's see what we have to confront with, because we are teaching in colleges. We are not teaching in universities. So first of all, we saw that the results of the PISA exams show that that there are problems. The teaching doesn't go well in Israel very much. Teaching mathematics does, which means that people who enter the university don't come with a very high level of mathematics. And I should also add that usually they take a break between finishing high school, a 3 to 5 year break between finishing high school and getting to the university. So they don't remember much from their high school. The Israeli system has a similar structure to many other countries. We have universities and colleges where students with high admission figures usually prefer to go to universities, and we teach in colleges, so we get students with low admission figures. It doesn't mean that they are not good. But still, another big problem is that cost of living in Israel is very high. And you're talking about an older population. They're about 23, 22. They have to work. So while studying, they also work. So we have to compete. Yes.
For those student jobs, how many hours per week? How much time it takes them to study?
They don't work in student jobs. They work.
Work.
Some of them work. Some of them have student jobs. Some of them it's very. Some of them, like if we have ultra-Orthodox students, they have families. They have families that they have to support. They have 3 kids, 4 kids, and they have to learn in this environment. So it's very challenging to teach them. So this is the setting. This is before we enter the class. So now let's talk about the test institution in Israel, because we want now to zoom into what we have experienced. So there were 2 test institutions in Israel. One, you can see them in the map. One is in Holon, which is a little bit south of Tel Aviv. I put it a little bit souther than it is, but never mind. And Jerusalem, which is over there. And please note that it is on the border with the West Bank, which is important. I will talk about it in a minute. So let's start with Hadassah. This is how the campus looks like. In June, you will be able to visit the place. This is on the right, you can see this is a 19th century building. So the size of the college is about 4,400 students, about 4,150 bachelor degree students, 150 are master degree students, and because Hadassah is located in the center of the city of Jerusalem, and again, you will see it when you visit. It's really, really, really at the center. It has a very heterogeneous population. So what the population includes. First of all, part of the student are general population, high school. This is the red thing. High school that students who learned in high schools according to the Israeli system. In addition, there are, you saw that this is on the, what used to be the border in 1967, so East Jerusalem was annexed in 1967 by Israel, but the Arabs there are learning according to the Jordanian system. So this is another system at all, different at all, and they also come to study in Hadassah. So they're studying according to a different system. And there is also ultra-Orthodox population, and they learn in a separate campus, and what they do for them is that they give them a year to kind of fill the gap that they have from their studies, and then they start studying in the university. So this is about Hadassah. Courses, the courses that applied to some degree in the courses Mathematical Tools and Calculus 1, the whole degree in Linear Algebra 1, Linear Algebra 2, some of the item concepts were implemented. So these are the courses at Hadassah Academic College. HIT, this is how the campus looks like. This is the new part. I didn't show you the old part, obviously. We have 4,600 students, about 4,150 for bachelor degree, 450 for master's degree, roughly speaking. And this is not a university in the sense that we have only special faculties: computer science, electrical engineering, industrial engineering, design, and instructional technologies. And there is a new program that started in 2020, digital medical technologies, where iTEM was implemented. So what was the challenge here? The challenge here is that in digital medical technologies, we have a population of students who wanted to go to pre-med. Some of them wanted to become physicians, and mathematics was not their core strength, or their ambition in life. So, this was the challenge at HIT.
Sorry, for getting enrolled into medical school in Israel, do you need mathematics on entry?
The question is not whether you need mathematics. You need mathematics, but the question is whether it is interesting. Whether it is interesting. This is not necessarily a medical school. Some of them will go to medical school. Yes.
Do they need mathematics?
Yes, but they don't see it as something that they do in their job. So it's kind of a kind of a boot camp that they have to pass.
Absolutely same as in Denmark, by the way.
Sorry?
The same as in Denmark.
Same as in Denmark, yes. So the thing is that they come with different knowledge level, and also they don't. The purpose is math is not seen to them as something that they have to do. Courses, calculus. There is only one calculus course and one linear algebra course in the curricula. So it's calculus, linear algebra, and some of the item principles were also implemented in the discrete mathematics course. Some of the three principles. Okay, so about the implementation of iTEM at Hadassah and Holon. So we have four principles. Actually, we have more, but four main principles. Real life as a motivator for developing new mathematics concepts, developing students' learning abilities, receiving feedback, and early identification of student at risk. So we start with developing student abilities and the manuals. We'll have a special talk about the manuals at the end of the day, but I want to give a highlight here. The manuals are telling students how to learn math and explain to them a methodology to learn math. We have an accompanied presentation. It also was translated to English, and I will share it with Kostas. And the problem was that at the beginning we just gave them the manual, and of course nobody read it. We gave them a presentation, of course nobody saw it. So we converged into a strategy where one of the lecturers, it doesn't matter which class, but one of the lecturers devotes about 30 to 45 minutes explaining the strategies to the students of how to learn math. Now, you will see in my next talk about the manuals that this is a very elaborate method. And students usually don't have the time to, I don't know if they don't have the time, they don't want to invest. I will put it this way, they don't want to invest a lot of time following all of what we said in the, or all of what we recommended in the manuals. So it seems on the face of it like a very futile effort to persuade them to do something that they don't want to do. But they do follow part of it. So some of the things they do, some of the things they don't do. And it depends, it varies between students. And what is more important is that when they are given a methodology, a path, for which if you will do this, you will know the material, the level of anxiety and fear reduces dramatically. So suddenly it becomes, instead of being something that is unachievable or unattainable, it becomes something that they can actually perform. And whether they are following the manuals to the letter or whether they are choosing what to follow, it really doesn't matter. I mean, it does matter, but from a certain perspective, it doesn't matter, because once they know that they can do it and they can achieve it, immediately it becomes something more attainable and something that if they put an effort, they will succeed. So this is one thing. Real life examples. This is the second thing that we wanted to do. Connect the mathematics with real life. And I will talk about the perspective of the students, but first of all, I want to talk about the perspective of the teachers. Because for us, this was the most important, for us as teachers, I'm not talking about the students, for us teachers, this was the most important contribution of the project. In what sense? It basically changed the way we teach. And why it did it? It did it because we suddenly, I mean, we knew it all the time, but we didn't know how to do it. We suddenly thought about our audience and not about trying to get a certain kind of material taught and write it on the board. We suddenly realized that we need to capture them. We suddenly realized that we need to be relevant to their life, to their lives. And it changed not only the way we teach mathematics, it's also, most of us teach, in addition to mathematics, other courses. And it has changed the way we teach other subjects as well, not only mathematics. Students love it. They really love it. Every time we have a real life, a good, because sometimes we don't have a good example, but every time we have a good example, there is they begin to talk between themselves, to the teacher, they ask questions. And what is important is that because we do that as an introductory to a subject, we don't do it at the end, usually. We don't teach something and then at the end we say, okay, let's now look at an example. But instead we use this example as a precursor in order to teach the definitions and the concepts. Students find it much easier to understand the lesson later. So now what you see here is the responses from the students. Now it's written in Hebrew, so I can tell you, I can tell you whatever, I can invent whatever I want here and you don't have a way to check it because there is no one who speaks Hebrew in the crowd. But I will translate what is being shown here. So this is a survey of one of the classes. I chose this one because we have about 3/4 of the students responded, who studied, responded to this survey. So it represents, it better represents what happens in classes. This was based on the Yes. So the left, sorry, let's start from the right. In the right, this is a scale of 5. 5 is the highest and 1 is the lowest. The question on the right is, how much do you think that the mathematical things that you, the mathematical subject that you study are relevant to your specialization, or to your studies. And what you see here is that it tends to the 5. I mean, most of them said, we don't know, but there are significant people who said, yes, it's relevant. To what level the course presented practical problems. And again, you see mostly 3 and 4, which means yes. And the last question is, to what degree do you feel that mathematics is an important tool to solve practical problems? And here you can see, that many people thought that it is, and very few people thought that it doesn't.
But what was the case before?
What I learned from the people from Weizmann is that you can't ask the questions. Because you don't have the same people. You cannot compare because you never have the same people. And the samples are very small, so. Okay, the other thing about building their abilities was working in pairs within class. And most students loved it and find it extremely useful. And I want to quote some of their responses. This is not from the Weitzman survey, but there is a survey. I wanted to take it from there because this was an unsolicited survey. It's a survey of their satisfaction from their studies. It is unrelated to item at all. And they have a free text. There is a place where they can put free text and tell what they think worked and what they think didn't work in the class. And this is what they said. The lecture combined work practice in pairs and groups, which made it easier for students who have difficulties in learning the material. This is one response, again, unsolicited. The teacher implemented teamwork, which contributed to the refinement of the material and encouraged us to solve the exercises. And the last one, the lecture gave practice in pairs, which contributed greatly to the understanding of the material. So this really works. The disadvantage of working in pairs is that it takes a lot of time because instead of showing one example in 5 minutes, it takes 15 and 20 minutes for one problem. So it means that we will be able to show less problems. In a given time, we'll be able to show maybe 1/3 of the problems. But the confidence that it gives students, worth it. So it's better to, I think, it's better, my experience is, it's better to give less examples and build the confidence of the students than to do more examples. Also, it's another problem is, another thing is that it works better if the teacher goes around and check what each one of the groups is doing and answer questions when they are stuck and help them if they are stuck. And this is problematic if the class is large. So if we're talking about 300 or 150 student class, this is infeasible, and this is why in the teacher's manual, and I will get to it in the next lecture, in the teacher's manual we recommended that this will be done in the recitations and not in the lecture when the lecture is large. And one thing that we unfortunately figured out is that it is infeasible with remote teaching. And the reason is because students don't have a good way to write or to share mathematical ideas if they don't have a tablet, because they can't write formulas. And we did it with other things. I mean, we took this idea, again, as I told you, we took ideas from iTEM and implemented it in other classes, and we did it in other classes, for example, in computer science. And when they have to program, this is not a problem because they have one of the students write the code and everyone see it, and it works perfectly well. But so the problem is not being remote. The problem is that we currently don't have the technology to share mathematical ideas. We have the technology to share programming ideas. Yes? For us, it just didn't work. We suggested it, and it didn't work. Okay. Yes, yes. So we worked with Zoom, so yeah. Yes, yes. Zoom, yes, yes.
Zoom provides you whiteboard that you can write.
Yes, but for that, in order to write, let's say, an integral, you need a pen, and not all of them have a pen. If they have a pen, it's not a problem. But the thing is that the vast majority of them don't have a pen where they can write with. Once they will have it, it will work. Yes?
Yeah, there is also an option to use the shared like whiteboard.
Yes.
And it is that the teacher can write and the student, which is the student in the group who has connection to the whiteboard.
Yes, but they need a pen for that. Not all of them have a pen, an electronic pen. This is the problem. Once they have an electronic pen, it works well. But the vast majority of them don't have that. And this is why I said, I mean, obviously we have the technology, but the students don't have the technology. Okay?
But yeah, you are correct on this. I mean, you cannot demand from all of them to have that. If you, in the Zoom, you have the shared board, and also you have the virtual rooms that they can be there.
Yes.
Only one of them to have a pen can direct the whole idea.
Right, but then you need to and create the division, and you cannot, if you have a class of about 40, you can't, it's very difficult to arrange these groups in advance, and it becomes very difficult. Okay, the other thing is visualizations, and of course students like it. We found visualizations more useful when we taught remotely, not when we were in class, because doing this in class means that you have to make sure that they see it with a projector, and they don't always see, and I mean, yes. While when we do it with remotely, it's much easier. And one thing that we saw is that students see the visualizations in class, and then they use the graphic tools at home by themselves. Yes? Again, when I'm in class, I usually don't sit in one place. I walk. I mean, like here, it's very difficult for me because the computer is there and I am here, and then every time. Okay. Yes.
Because when I write with the tablet, the students in class see it, the students online see it, the same thing.
Yes.
Here, and that's it.
Feedback. We found we implement, of course, the test in Moodle, but we find it to be very problematic. In the Israeli settings, I don't want to say anything about other places. I'm talking just about Israel. There was a question when to release the tests, because students not always, again, students are sick. They have sometimes they go to military service. They work. Usually their grandfather or their grandmother dies, and you know all of this stuff. Yes. So when we put the test online, they usually ask for extension and another extension and another extension, and we end up giving them, and because we don't have to grade this, and of course there's the question of fraud, we end up giving them the ability to do because they are compulsory, we end up giving them the ability to do the test until the day of the exam, which means that we don't have a feedback. And they don't have a feedback. And obviously, there's a lot of time to prepare these tests. Other options like Kahoot are also problematic because not all the students attend the class. So the people that we want to catch with this immediate feedback are not always the one that will get this feedback. I mean, we can get feedback about how good the class is, but then the students that we want to catch, these ones that are at risk to fail, they probably are not in class. So, so this is a problem. It works, but it doesn't work as well as we thought at the beginning in providing us feedback. Project-based learning is also something that we find problematic because with the time constraints we have, because we have to cover a lot of material, we can have only small projects, and we have to increase staff in order to implement it, and obviously we cannot. What we can do is to change the homework that we give so that they will include real life problems. We haven't done that, but this is something that we think to do in the future, because we don't, right now we didn't have resources to do that, but we hope to do that in the future. And also what we think needs to be done is to connect not only to real life, but to connect the problems in mathematics to other courses that they learn in parallel. That will give a synergy between classes, but this would be very difficult to do because synergy between courses in academia is very, we find it very hard to do because every teacher, or every group of teachers live in their own world. Yes. So, early identification, this is something that is early identification of students at risk to fail. It is not being done at HIT. I will talk about it in a minute. But in Hadassah Academic College, it was performed in parallel with, and really as a consequence of iTEM. The idea, we surfaced the idea to the people in Hadassah, and they decided to do it campus-wide. And they generate a report about the activities of the students in Moodle. And the problem that we have with that in terms of giving early identification is that information arrives late because it takes time for them to submit homework. It takes time for to grade them. Students can be dishonest. So it provides information, but it's not as good information as we thought at the beginning. So it's a very crude tool. It identifies the very problematic students, and then these are the ones that we try, at Hadassah, we try to connect with them mostly unsuccessfully. But the people that we want to catch are not the people who are really going to fail. We want to, because for them probably we're not able to help. We want to catch the people in the middle that are about to fail, and for that we don't have a good system. And what we think we need to do is we need to design activities, not activities that we have right now. We need to design activities that will leave a mark in the education management system, so that we will be able to catch it. So we don't have yet an idea of how to do that, but we think about it. We need to devise something that will really be immediate and that we will really be able to measure and not measure in 3-4 weeks later. And of course, we have the elephant in the room, which is COVID-19, which really was not only a health hazard, but also an educational hazard, in the sense that it prevents us to do some stuff. Remote teaching was difficult, and most of the time we were trying to survive the teaching. So it was very difficult to implement iTEM in this environment. 2 minutes about what students say. So again, this is in Hebrew. This is from the this is from Holon. And this is from the Weizmann survey. And what you see here are subjects. And what the students say here is how well they feel that they know the subject. And again, 5 means that they don't know the subject. Blue means that they feel confident that they know the subject. And it really doesn't matter the subject itself within the course. But you see here that on the left you have the things that they learned earlier. And on the right you have the things that they learned at the end. And what you see is that there are no purple. Purple is 5. There are almost no 5. There's a little bit 4. Most of it is around blue, green, and yellow, which means it's not difficult, which I think is a great achievement of our approach. And the other one, the last one, is about, and this is something that we haven't talked about too much on iTEM, but I think it's important. It's about the emotional aspect, because when the students see that the teachers that it is important to the teachers that they know, they also invest in their studies. So again, purple is high, blue is low. How much do you feel that the course team was cared about the difficulties you faced during the class? And you see here that most of them felt that the course team cared. At what level you feel that the teaching team gave you support and help? And again, you see that most of them felt that they got the help they need and was available for questions. And to what level you think that the course team provided you with effective learning tools to confront the material that's studied? Again, it's 4 and 5, and this is 75% of the students. So it means that our approach is really, really good, but there's also a lot of place for improvement, and I believe that you will do that in other projects. Thank you very much.
Transfer. But they should listen you.
Nisim, what's your opinion comparing two students? First one, for example, working and studying, as well as second one, for first one, necessary money for supporting his family, for example. A second one, not necessary, only studying, more studying than, as well as at the end, which one is more capable in the future for working good? What do you think? Thank you.
First of all, I think that the idea that when I went to studies, I'm very old. It was in the 80s. It was very common that students didn't work. I mean, it was not the norm to work. You went to study, that's it. Maybe you took a menial job, maybe 5 hours, 10 hours, 20 hours, but nobody really learned full time, and actually the universities didn't encourage it. And this works well if you are working with higher middle class students who can afford not to work, sorry. But when you think about expanding the higher education system to students from lower economic levels, then this is unreasonable assumption, because they obviously will have to work with, because they don't have the resources. So I think this will be the norm. So we have to adapt. It's not that we have the choice. The other choice is to keep the higher education system available to a very small minority of the population, which is not where we want to go. We want to go so we have to find ways to accommodate students who have to work, which means that we have to be more flexible in terms of how many classes they take in a semester. When I was a student, it wasn't available. I mean, this was what you have to do, and that's it. You couldn't take less classes. So we have to do that. We have to provide them with a lot of help during the studies, and also we have to be more give them better tools to use the time effectively, and we have the ability to do that if we will take the time to do that. The question is whether we have the resources in order to provide them that, and this is very difficult.
Okay, why I am asking, because nowadays our government allowing to work about all students as well as studying. So I am worrying about our future education system. Thank you for answer.
Any other question?
It seemed very interesting presentation, and it's the first time we learn about the education system in Israel. It's really interesting. Thank you. So my question is, it's very important, the working teams. Do you do work in teams or work in pairs? Or like, is it a team of 2 or a team of 3 or 4?
We do it in class,
okay.
and we encourage them to do that afterwards. Yeah. What I tell them is work in pairs. If you want to work with three people, that's fine. I'm not, but don't work alone. So usually they work in pairs, because it depends on the way the class is laid out. Usually they sit, it can work up to 3, because 1 in the middle and then 2 on the sides. And if they sit on a table, then you have 2 people. So it's more a matter of the way the class is built than on educational strategy.
Yeah. Well, the question was, do you decide which students form a team? Because it's very interesting. It's very good if the team has 1 good student at least. So this good student practices more by teaching, and the lesser students then learn by listening to the good student. Because if you have a team of only bad students, then there is no future, you know. Or if you have a team of very good students, then there is no reason to form this team. So if you had control of how the teams were formed, then you would have better examples, better results.
You're right, but there are 2 problems. One is that I don't know, apart from very few students, I don't know who is good and who is bad.
Sure.
So I can't do that, and also it's already time consuming. So assuming that I will have to, I have to change them their locations during the exercise, it will take even more time.
Sure, but that would be the ideal.
But I think yes, of course. But I want to say one thing is that it is also good for the good students, because one of the things, and I keep saying that also to the students. I tell them, when I learn something, I have in my head the idea that I understood it, but I really didn't understand anything. Until I come and practice, I'm not sure that I got it.
And unless you teach, you don't understand it.
Yes, and so what happens is that even if they think they know, and even they're very good students, and if there are 2 good students working together, they still benefit from doing this exercise.
Thank you very much.
Because of my experience, which lasts a little longer, not from the beginning of iTEM, we started doing that. It is randomly chosen the pairs or triplets, but you have to count with individuals. They are not capable to join. And you have to respect these people.
Yes.
And it is that sometimes the one who stays isolated then sooner or later realizes that he cannot catch. And when I asked him or her later during the semester if he would like to join somebody, then sometimes it helps.
Yes.
And it is that the profit, each side profits from in-pair learning, even though they are different level or average, almost the same, because they practice their ability to listen and to speak. And both is necessary for math.
Yes.
Thank you.
So Nisim, yes, first.
Thank you. Very wonderful speech. I wrote a bit my question, just not to forget. You talked about students' aspiration, and then you know the students are different, they have different interests. And then what would you say to a hopeless student? How would you encourage a hopeless student, for example, who says, for example, my success at my tertiary education, and especially excelling in math, doesn't correlate with my success in my work, in my future work or in industry. How would you encourage them to learning math?
So this is the problem. So what I want to show, I mean, I teach computer science, so it's very easy, because all I have to say is that we model the world and we solve problems using math. But again, the more you give examples on how the math relates to the job market, then this would do the trick. Now, sometimes the reason students say that is because they don't want to invest the time learning math, and not because it's not important. And then the question is why they do that, and why they don't have the time to invest. And sometimes it because of problems of work, and we need to be sensitive to that, because maybe the problem is not math, the problem is external. And again, we should try to provide them with help with that also. I mean, for example, do less classes.
Yeah, for example, we talk every time in class with visualization. We talk about in class. How would you, for example, visualize their aspiration? For example, I have a little brother who now studies in Germany. And then when he was studying in school, I brought just a big billboard. Very successful student is studying in Germany. It's like just visualize and just put that poster in the. How would you visualize their aspiration?
I'm not trying to do that. I'm trying to be there for them. I'm trying to visualize math, not their aspiration, because they come with different aspirations. But what I can do is I can persuade them by showing them how this is relevant to their life and how it is interesting. And once you're engaging, people ask me, what do you like to learn? Usually I tell them that it depends on the teacher, it not depends on the subject. Because if the teacher is interesting, even Hebrew grammar would be interesting. So it really depends. If you build an engaged class, and people are engaged and they feel part of it, it will work. They won't think about whether it is good for their aspiration in life. So and this is what we're trying to do. So I have to stop. Yes. So.
Thank you. Sorry, we have to go to the last contribution of today's morning session. And this comes, we have an online contribution from Adrian Mundean, the General. A few words about the speaker. He's a professor in Carleton University in mathematics. His research interest includes understanding, translating, and exploring in mathematical terms the physical and social world around us. He has a very nice initiative, Industry Meets Mathematics, where the students are called within a day to solve a real-life problem using mathematics. So, Adrian, the floor is yours for the next 40 minutes. Can you hear us? You are muted. But you are muted. Say hi. Say hi.
Hello, everyone.
Okay, excellent.
I did send a video with my recording, so I rely on that that maybe someone from the exactly runs it.
Okay, we are going to play the video.
For the people in Meet, I'm not sure if the sound is going to be there, but I'm going to send the YouTube link so you can hear it there.
Did you share the audio?
Hello, everyone. My name is Adrian Muntean, and I'm professor for mathematics at Karlstad University in Sweden. I'm going to talk in the next 20 minutes about mathematics with industry day, which we are organizing in Karlstad. And I would also like to have a glimpse to 5 years back and tell you a few things we did in Karlstad, me and my colleagues, and the students which work with us. So let's move on. The core team is made of Elisabeth Melroth, which is a high school teacher in Karlstad. She's expert in education of gifted students. She has a PhD in this direction. And myself, my expertise is mostly applied analysis, and I'm interested very much in mathematics and its applications. We are co-owners of this idea of the MIM Day, Mathematics with Industry Day, which is a registered trademark. You have all information about it. You can find it on this webpage, and where you can see the clear rules of the games and lots of it, on all the industrial problems we had, in fact. So information is all public. And I'm going to tell you a couple of things which I believe are more relevant. So this is how my presentation is structured. I would like to tell you why there is a need that mathematics meets industry in one day, at least in one day. I will tell you briefly what is our precise concept. I would like to use this opportunity to tell briefly about at least one of the industrial problems we treated, and I will pick one from last year. What do we gain via organizing or via having such a mathematics with industry day? It will become clear. Very briefly, I will tell also what can I say about these 5 years? What did we realize? And there are a couple of things we could have done better, but some things we did well. And I will also like to tell you when the next Mathematics Meet Industry Day takes place in Karlstad, and I would like to offer you to place this as an open invitation to any of your students who may want to participate. So, scrolling down, I believe the current situation is really that our society is increasingly technological. A lot is requested from us as simple citizens to understand, to use a lot of technology and to make sense of information. We are overloaded with information. Sometimes in our job, we need to be increasingly better on various kinds of softwares which are changing very often. So we need to be very adaptive and flexible to the next day. A fact is that the industry, and now I'm talking mostly about the local industry, likes to hire highly specialized people, and local industry prefers somehow to have people from the neighborhood, from local people. Everything that matters is multidisciplinary. I'm mostly interested in training mathematicians, so if I'm having in mind the profile of a student in mathematics, I'm not only worried that the student, he or she, or they like to or need to acquire mathematical knowledge. It's also important that these students are aware of what happens in chemistry, physics, information technology, and so on and so on. At least a minimum needed for communicating with other colleagues or future employees. Also, as current situation, a lot of hands-on skills and excellent communication aptitudes are needed from us and from our students. One thing which you have in mind is that we observe even at our university that smart kids, smart children have very much difficulty to focus on tasks, and everyone likes immediate reward. If the reward is not there, then maybe the task stays not done, even very simple tasks. On the other hand, smart kids can handle much more than they are given. If they are interested and motivated, they can handle more tasks at once. They can overcome the capability of the teacher. And we are interested in growing successful young people and growing the teachers for these successful young people. So this is basically why we do care that mathematics meets industry in one or another form, because I think we have things to learn from each other. Yes. So what is mathematics with industry day, in fact? It's a one-day event that the title tells it. But what happens in that day? Companies, selected companies, come and present challenging problems, usually during the morning, early in the morning. Challenging problem means especially that the company does not know the solution. This is a problem which company would like to understand or will have at least a partial solution, and they do not know it beforehand. And they expose it to a mixed group of mathematicians which are supposed to work in teams on those problems. After, of course, during the day is short, people work a couple of hours during the day on the problems, and at the end they are supposed to present briefly the results to the company, and the company are going to evaluate the results. There is, to have things running nicely, there is a lot of coffee and sweet things available and food during the whole event. And the company people are there with us, are there with the teams during those days, during that day. This is really essential, that the contact between the problem owner and problem solver is very good. So this is it. This is the MIM day. It is a very interactive event. there is no time for a real break. Even in the breaks, people talk about the problems and keep on trying to investigate, do a sort of detective work. What can we do? What sort of routes can we, investigation routes can we take to tackle our tasks? Okay. Example of industrial problems. All the industrial problems are placed on this website. So in 5 years, we had each year 2 or 3 problems. So we have between 10 and 15 problems published there. Solutions, you will not find solutions. You may find hints to partial solutions, but you will find a lot of background on the problems itself, as well as the contacts with the problem owners if you are interested. Now, one of the problems we've got last year, it was in fact from a German company called TESA. It's based in Hamburg. And TESA cares about adhesive bands. The title of the problem was Modeling Solvent-Borne Adhesives. Now, you are asking mathematicians these sorts of problems, and you are wondering what this has to do with mathematics. So I will not have time to explain you this, but just to give you a flavor about things. What is an adhesive band? We all have seen various types of adhesive bands. Well, TESA does very specific bands, very highly specialized adhesives, which you find them sometimes inside your cars. And they are here. You could see here an example is in this picture from the left. You see here 3 different types of adhesive bands. So what happens basically, you can pick a bit of, you can take it from a corner and you can try to peel off the one layer of the band, and then you glue it back and put it back. It will glue automatically. And you can repeatedly do this action and without breaking the band itself. If you break it, then the material is destroyed. You would have to use a different adhesive band. For highly functional devices, when you have these sorts of closing or opening of a certain bag or binding of 2 materials, and it is done by an adhesive band, the connection and disconnection should happen perfectly. So materials have to be very good. So the task we were given were to try to model what is here. So now the whole modeling was basically consisted in looking inside the microstructure of this band. And after discussing with the engineers from TESA, we reduced the problem to a system of mixture of 3 types of particles. You see here in the picture from the right, yellow particles, blue particles, and red particles. And they were all mixed in a box. The box was supposed to be, was supposed to be close to the thickness of this adhesive band. And particles were interacting, and the red particle, called solvent, was supposed to evaporate because of a heating treatment. Now, after evaporation, you are left with the internal structure of adhesive band. So now, what was that internal structure of adhesive band? This is mostly the yellow and the blue parts here. Blue is rubber. Rubber gives this rubber type particle give elasticity of the material. If the material would not be elastic, it would break after the first use. Okay, so, but it doesn't glue. Rubber does not glue. So the yellow part, acrylate, likes to glue. So basically this combination of blue and yellow gives some sort of flexibility to glue and unglue a certain band. Of course, the company wants a design that has a specific design in mind. They would like to see how to design interaction between particles such that this, say, blue patterns are localized in very specific zones. But that becomes a design question. Our task was simply to model the process, and with very simple mathematical tools, in this case it was a stochastic process, to obtain this pattern formation. Now, of course, more work is needed if one wants a specific design of these rubber structures or a certain speed of evaporation of the red particles and things like that. During that day, we could only show that in principle, you can use mathematical tools to simulate the internal structure of these bands, adhesive bands, without any cost of material. So in principle, one can test by means of numerical simulation, extreme situation, which one should do or one should stay away. So, which basically delimit a bit the parameter testing also for a true experimental setup. So, okay, that's it. I would like to move on. The details of this problem will appear in a master thesis of one of our students, which is supposed to finish the work in June. So what do we gain from a mathematics with Industry Day? First of all, we allow everyone to see how mathematicians think. Who is this everyone? First of all, the company people, they see how mathematicians think, but also the students see. The typical composition of a team to such a mathematics with Industry Day is the following. There are one or two experienced researchers, a couple of PhD students, one or two master students, one or two university students, 2 or 3 high school kids from the last year of their studies. So we have very different people of various level of seniority. This gives an occasion for the young people to see how the more experienced people think. I think this is a very important, how to say, advantage of such a day. Because all of these people, or let's say with their big majority, for the first time, they're supposed to work with an adhesive band problem. This kind of a problem is not something which a mathematician does in everyday work. But we could work on these kinds of problems if we receive a certain amount of information, enough motivation to work on it. We can contribute as well. We can ask very different questions than an engineer asks. And I think the combination between us and engineers makes stronger teams. This certainly shows to the high school children that studying natural sciences makes sense, that you can contribute to what the technology or what the society nowadays wants. You have a fair chance to contribute. We also train our researchers in pure maths, which are typically trained in pure mathematics, to look also to more applied problems and to care also about the applicability of their everyday work in the outside world. And of course, by this activity, we create a natural contact between mathematics and industry and society. There are a number of difficulties when organizing such a day. How to select the right industrial problems? There are many industrial problems. There are lots of companies offering very difficult problems or very simple ones. How to choose the level of difficulty of a problem? Okay, once you have chosen the problem, how to decide who is going to work in a certain team? Do we need a moderator to to facilitate the communication between the problem owner and the team or within the team. How big should the team be? What should be the natural fraction of boys or of girls inside the team? Where to find people which are keeping teams together, the so-called group gluing people. Okay, nowadays, these kinds of events, which are typically highly interactive, had to suffer because of the corona. For instance, we succeeded to make it corona-proof by moving it online and trying to survive our interactions and our interactive style in online form or in a hybrid form. Now it seems that we have to adapt to this war-proof, to look for a war-proof concept, because there are more obstacles which prevents people to join in a place and have fun working on certain problems. I forgot to mention, the event is organized in Sweden, in Karlstad, but it's open to everyone from everywhere which is willing to spend time and to work on the problem. They can reach in person or they can reach us online. So it's not a specific Swedish event, it's quite international. Also via the participants. Well, time has arrived to say a few words about our activity report. We are 5 years old, we have some things to tell. Many things are not really measurable, but some things are measurable. For instance, in 2017, we decided to write a research proposal with one of the companies on their problem. And we wrote it and applied twice, and we were twice rejected. But while working on this research proposal, we also published a scientific article, and there was a follow-up popularization article on the work. So these things have been realized. 3 master theses two are completed, one is on the way to completion. They came out as follow-up works from this Mathematics Wednesday Day. 2 were on the modeling, analysis, and simulation of hypoxia in connection with cancer growth. And 1 is connected to the problem I was telling before about this mixture, rubber, solvent, resin, acrylate interactions in making adhesive bands. Yes, but also because of the many companies coming and presenting problems to us and interacting with us, there was some buzz in the media and also in the local press, which for mathematics is always good, that people see that mathematics are present in the community. Yes, we interacted with research and development people in the industry. In our case, during 5 years, we interacted directly only with 7 companies. You have them here enumerated. As you can see, Ude Holm times 3, which means that the company Ude Holm participated 3 times in a row, and many others. Of course, our interest is to let as many companies come and interact, to show also that mathematics is rather universal, that if we succeed to communicate and to understand what it's about, and we can translate the problem, the physical problem, into mathematical terms, then many disciplines can be involved, many types of problems can be involved, many types of companies can be involved. Okay. Yes, we failed with the research proposal, but at the end, quite recently, we succeeded to get funding for a 5 years assistant professorship to join my group in Karlstad with expertise in industrial mathematics. And this proposal was successful because, again, these companies who were participating in the mathematics industry, they also participated in this say, capacity building, if you want, proposal. And now the team for working for this Mathematics Wednesday Day is much bigger, and then we can take care of a more intensive follow-up. the interactions during the day, the meme day. Okay. Next, Mathematics Wednesday Day is going to be on December 15, 2022. Most likely, it will be in presence. So company people will be with us, and most of the participants will be there as well in the room. But also, we'll offer the possibility to join online. We learned that if people are motivated and if we find a right way to interact together, then hybrid forms should be maintained, at least for such an event. Registration will open soon. Soon means at some point in September, October, as soon as we have collected 2 or 3 industrial problems. I am continuously searching for industrial problems. So if you have in mind something or you have connections of people or companies that could have something challenging where to put mathematicians in difficulty, just let me know. Participation is and will always be free. Sometimes we can help people we can participate at least part-time to travel costs so that people can join us in presence. But what is a must is the activity and the motivation of the person. So if someone joins, has to have a very active and proactive way of interacting with the others. Of course, we can only handle a limited number of participants. Reality says that a good group is like of 8 people, of a good team. So maybe teams can be extended up to 10 people. So which means for 2 or 3 problems, you already have an idea how big this Mathematics Wednesday Day can be. So if you want to participate, just get in touch with us early on. So feel welcome to join. If you want more information or wish to interact or collaborate or take over this concept and apply it in your own country or in your own network, in your city, just interact with us. Just write me and I will see what I can do to help you or to help each other from a distance. Thank you very much for your attention, and I'm looking forward to interact with you in a way or another. Bye.
So thank you very much, Adrian, for this recorded session. Are there any questions? Just a moment.
How difficult it is to create it in another place? I mean, how much effort do you put in order to design, let's say, the second event in 2016, sorry.
Did you get the answer? Did you get the question?
I got a question. Let me. So, can you hear me?
Yeah.
I think the difficult moment, the most difficult moment is the first time you do it. Because once you did it the first time, then it's somehow easier, because the same problem, the problems are the same. Team composition, this interaction in the group, yeah. It's not really, I do it in Karlstad because I'm based in Karlstad, and it's important for me that the city sees there is a math department here, so that we are present here. Otherwise, I could do it in the neighboring city or someone else in Sweden or in Jerusalem or something. So this is my main, one of the motivations which pushed me to organize something here to show our mathematics students that there is a large employability spectrum. You don't have to be a math teacher per se. You can be whatever you want, provided you have the right set of skills. So I think it's possible to organize it somewhere else. You need, but if you do it somewhere else, it's better than the local companies from the place where you want to organize, they participate. I think this is maybe the only important thing. Well, I had a German company coming, but that was rather extraordinary. Usually we have the local companies participating. Did this answer your question, Anisim?
Yes. He's satisfied. So,
okay. So it's possible.
Just a moment, there's at least 2 more questions because I have a question. No, the older first.
Hi, Adrian and Rodrigo.
Hi, Rodrigo.
I would like to tell to the people that Costas and me, we stay in the Industry Day 3 years ago before the pandemic. And I suppose that Costas agree with me that was very, very exciting day. It was a great, great experience. And I have to tell that for a mathematician was a very challenging day because I have the opportunity to share with another mathematician in my group, and I have to realize here the door is closing. They were totally frozen. They were not able to generate any idea or involve in the problem. They was very overwhelmed. The student was all the time talking, interchanging, changing the ideas, and so. And I really feel myself overwhelmed. And I have the comment that in our group, there was some people from secondary school that Adrian interchanged between the university students. And exactly in the problem that we were working, the best solution was proposed by the secondary school students. They stayed quiet, doing all the calculation with pen all the time. I assume that they were overwhelmed because there was one master student with computers, people doing the PhD, working with MATLAB, and so. And these students from high school were with the book notes, pen, very quiet, and I say, oof, these people never went back to this experience. And at the end, one guy hung up and say, why don't we do this? And everybody says, you are right, and was the best solution because we didn't find the solution. The student discovered that the company was hidden information. The main conclusion of our problem was, it's not solved because we need more information. And the representative of the company says, you're right, but it's secret. it's not possible to say here because then I am fired and so. And was an excellent moment. There was no solution, but there was a common idea that what is the barrier, we have tried. Even they were talking about artificial intelligence, whatever. They were jumping between the tools so fast, and I understand that there was one Asian guy that he says, I am from applied mathematics, but I can do nothing here. From Thailand, yes. It was really was a few hours exciting. I finished exhausted, okay, because I assume more or less the role to try to communicate between the people to make the chance that everybody talk. So my recommendation, try to do it in your schools, in your university. Try to do it. Start with simple problems, academics, or some research paper. If you have difficulties to find a company or industry, that will appear later when you start to enroll more people. Okay, but try to do that. One day, thinking with wide mind, no barriers, and so. You were also overwhelmed. You were in the problem of cancer, I guess, no?
Yes.
I guess. But I mean, right now the Erasmus projects and through the central activities and budgeting that each institution is receiving, they organize the blended intensive programs. And one of the issues about the blended intensive programs, probably, Adrian, you should contact your international relations office, is like to organize hybrid events. So multinational teams, they are meeting, at the beginning online. So an online, you can start your event online. The companies, they can present the problem, and then the teams, they are working together, for a week or 2 weeks, and then a face-to-face meeting happens, and everything is getting paid and supported by the Erasmus. So check with your international relations office about the blended intensive programs, because they have received funds to organize this. So you can extend the 1 day with a multinational event that can happen at the beginning online, so we are going to give more time to the teams to collaborate, and then they are going to come to Carlsbad and meet face-to-face with the people from the industry. So check this opportunity. Then if you need more information, I will give you more information and I can direct you.
Can I reply to Rodrigo, please?
Yeah, of course.
So yes, Rodrigo, you are right. So
it was no question, that's why. I was not.
The speaker made question. This is terrible.
It is also connected to Nissim's comment. The success relies in the motivation of the people to participate, but also in the seriousness of the company. If the company puts a fake problem, the 8 or 10 people are going to discover it. If the data is prefabricated, it's not real data, people are going to discover it.
Yes.
And then it's frustrating. That's probably what happened in your case, that the data or the problem was missing information, which basically stopped the team working.
Totally agree.
Another thing, sometime, I think 1 year after or 2 years after, maybe the first time when Corona hit, iTEM was involved in such an event, and a very active team from Nissim came online, and I guess also Nissim saw the problem presentations and maybe the solutions in one of these events. So Nissim students were involved in one of these problems successfully. I'm stopped.
Okay, so I have a question now. You mentioned at the beginning, I kept 2 statements during your presentation. First of all, gifted people, gifted students, and the second one is like a question that you made, how many girls and males should contribute, the group. So my question is the following to you. Are maths only for gifted people? And second, why the gender balance affects the performance of a team?
It's the first question, it's easier to answer. The second question I cannot answer because it's not my expertise, but I can start with the second one. Diversity, the mix makes teams very strong. So because people think in different ways, they have different perspectives, they have share different sorts of information, and it's always good to do that. If you don't do that, you are more or less, you are going to be biased in a strong way. Math with gifted people, math is not for gifted people. Math is for those who need math. So again, I'm referring back to Nissim's talk. It's about the motivation of each one to do things.
But the motivation is related with the intelligence?
It overcomes my level of expertise, because I'm not a psychologist, I can't tell you that. I don't think so.
Yeah.
Motivation is motivation, and intelligence is intelligence. But what I noticed, at least in the Swedish academic system, that gifted people are typically lost because they lose motivation very early on. And then it's my attempt to discover gifted people in fact in weak performing students, because the students we get in Karlstad are not per se the most successful ones. So then, but I'm still a strong believer that there are many good people here, but it's not easy to catch them. And one way to do that is that if they volunteer, participate in such events. They just step out of their comfort zone.
And based on your experience, how many girls and how many boys do they participate in the event?
In natural sciences, we don't have many
Exactly.
girls, so this is a big problem. But I always pay attention that each team has girls.
Thank you.
The number doesn't matter, but you shouldn't be 0.
Thank you. Do we have any other question? 1, 2, 3. No more questions. Thank you very much, Adrian, for your contribution.
Bye-bye.
Bye. So I suspect now it's like quarter to the hour or 10 to the hour, and the lunch starts on the hour, no? Yeah. So we are going to stop until 3 o'clock, and Eva will be the moderator, in the evening session. Okay, so thank you.
Presentation I was presenting yesterday, okay? Yeah, so I will do it from my computer. Just tell me where I should upload.
I think the easiest way is to send it to the same email as yesterday, via Drive. So
tell me the name of, or write
okay.
me.
So if you search, well, it's Google Drive. Google Drive.
Google Drive.
It's just like a folder, let's say, but it's in the browser. So you grab the presentation and you just put it to your unit.
I will put it in there.
And then you
Google Drive, the name.
And then right click it to share with.
Yeah, the address.
Yeah,
this address. Okay.
At
Perfect. I'll try to do it.
If not, let me know and I can help you.
If this was mine or yours.
I think it's yours. Yeah.
Okay.
If you need help, I can help you.
I will do it right now.
Okay.
So I'll come with you.
Agenda. So today it will be Javlon first. Javlon from the Uzbekistan National University.
I will take a picture.
Yeah. I think this computer can move it. So this is the 4 that we are having today.
Yes. Just a minute.
It's the middle one. So it will be this 4. Sorry, John. I'm not sure if I'm pronouncing it correctly.
It's Tashkent University.
I don't know. I don't know how to pronounce it.
Nissim Barel, Lorbatel, and Yablon Kermet. Yeah, these are Uzbek, and that's the Israel.
Yes.
Okay, thank
You're welcome.